Hello friend, in last lecture I have discussed the electron beam machining process. So today we will continue that process. As you can see that in this part we have a vacuum, and this whole uh, system is under the vacuum. So why we require vacuum, then we will discuss, and how vacuum is created. You can see that we have a nozzle here and we have a cooling coil. As we hit the water, what will happen? The vapor particle moves in upward direction. Okay. The main element for creating the vacuum is diffusion pump. The coil diffusion pump is operated with an oil of the low water vapor pressure. It proposed as to achieve the higher vacuum. So diffusion pump is essential an oil heater. As the oil is heated and the oil vapor rushes upward where the gradually converging structure, the nozzle changing the direction of the motion of the oil vapor, and the oil vapor start moving downwards at high velocity as a like jet. Such high velocity jet of the oil vapor entering any air molecule present with the gun. So due to high momentum, oil of jet air is removed. The oil is evacuated by the rotary pump via backing line, and here we have generating the vacuum up to the 10⁻⁴ to 10⁻⁶ torr. So basically this is a whole arrangement. We can see that we are hitting the oil and it will travel from the bottom to upward direction. We have a number of convergence shapes, so it will ultimately removed by that convergence shape. That will, if some particle is there, that will carry by the oil, and that will be replaced by the backing pump. Now this is a very important part in any machining process, the mechanism of the material removed. How material is removed in this machining process. As a high voltage is applied across the cathode filament, thermionic emission of the electron takes place. As we have discussed in last lecture, that cathode filament is made from the tungsten or tantalum. So as we supply electricity to that filament, it will generate the electron. These thermionic electrons are rapid. These thermoionic electrons are applied by the cathode and attracted by the anode through the bias grid. So cathode and anode is kept at some distance, and bias grid is placed between these two charges. Electrons are accelerated to the half of the velocity of the light. This electron beam of the electron is shaped and focused with the help of series of magnetic and electromagnetic lenses, as we have discussed in the last part. Finally, the electron beam impinging on the workpiece. Upon when beam or we can say electron beam strike on the workpiece, the kinetic energy of the electron is absorbed by the workpiece, which will result into heating and melting and evaporation, vaporization, that generate the drilling. spot size is 10 to 100 micron, high energy density. So as this is a very simple process, that what we are doing, we are generating the electron, and electron is guided with a different arrangement and lenses, like optical and magnetic lenses, that will be generate the high kinetic energy, and this high kinetic energy electron strike on the workpiece, that will be resulted into heating, melting and vaporization. As you can see, this part is the in first figure workpiece, and at the bottom we have table. So as electron strike on the workpiece with a very high velocity, it will start melting, and gradually it will move into depth. As you can see in second figure, as we focus on the single point, suppose we want to generate the hole in an workpiece, so we have to focus electron beam on the same point. So it will gradually remove the material by the vaporization and melting process. So that will generate the hole on the workpiece. So suppose you want to cut the machine, you want to cut the workpiece with the desired shape. So you have to first focus the point on the workpiece, then you have to start the program. You can see in this first figure, penetration till the auxiliary support. So in the bottom we have a support. You can see that up to that point it will generate the hole. But if we focus this electron beam on that point, it will also start melting of the auxiliary workpiece. So the auxiliary workpiece also replace after the some cycle, because it also got melted during the trailing operation. In other operation, like you want to make the cut, so in that case auxiliary workpiece will not damage. So this material removal mechanism is very important in any machining process. Even if we study the conventional or any other non-conventional, like AGM, ADM, grinding, in each and every machining this part is very important, because if we start the modeling of the machining process, we require each and every parameter that should be included in MRR. Even we can find out the surface roughness model by considering all the process parameters. So this machining process also include the number of process parameters like voltage, current, even feed rate, depth of cut, even electricity, that is voltage and current, as we have discussed. Because if we increase the supply, then it will generate the high electron, and it will increase the kinetic energy. So this process parameter is very important in any machining process. Then we will discuss in the next lecture about the process capabilities and advantages, disadvantages and application. because every technology has advantages obviously, but it also carry some disadvantage compared to other machining process. Thank you.